Hello, sir.
Yes, sir.
Today we'll discuss area of sector or segment.
Okay, sir.
So, area of sector. Area of sector or segment. Area of sector or segment. So, what is sector? Suppose this is a circle and the circle has the center this, and if I am taking an arc, for example, an arc I am taking, this is an arc AB. This arc AB I am taking, this is the arc, and this is also the arc. This is shorter arc, so this is known as the minor arc. This is known as the minor arc. This one is minor arc. And this one is known as the major arc. So if length of this arc is L, length of arc AB is equal to L. Arc AB means minor arc. Then what will be the length of the major arc? 2 pi r minus AB. If r is the radius, small r is the radius of the circle, then length of major arc, length of major arc is equal to 2 pi r minus L. Why 2 pi r? Because 2 pi r is length of whole circle. And when you will subtract this length from the whole length, you will get this length. Means length of major arc. Okay. Now we will discuss what is sector of a circle. This is a circle. Center. Suppose an arc is there. This is an arc. AB. And this is a center. And if you will join this AB, if you will join this AB with the center, or A with the center, and if you will join B with the center, then suppose this point is O. So this OA is also the radius and OB is also the radius. So this part is known as the segment. This part is known as the segment. So there are two types of segment. One is the major segment and another is the minor segment. So this smaller segment of the circle is known as the minor segment. Oh, sorry, minor sector. Sorry, this OAB is the sector. So this is minor sector. Sorry, this is minor sector. And this larger part is known as the major sector. Is known as the major sector. Now we will see what is segment of a circle. Segment. This is a circle and center of the circle. If you are drawing a chord, a line passing through any 2 point of the circle, any 2 point on the boundary of the circle. So I am taking these 2 points. One point is this, a line passing from this point and this point, and this line is known as the chord, CHORD chord. Okay, this line is known as the chord. So if this line is known as the chord, so this part is the segment of the circle. This is also the segment of the circle. There are two segments. This is minor segment. This is the major segment. Minor segment. And this is major segment. And what is chord? Line joining any 2 points on circle. Chord is the line joining any 2 points on the circle. Okay, so after this, we will discuss how we will calculate area of sector and area of segment. How we will calculate area of sector and area of segment. First, write down this. Done?
Yes, sir. Done, sir. Done, sir.
Okay. So now we will calculate the area of sector. Area of sector. This is the minor arc. This is the minor arc. Okay. If you will join this point of arc A with the center like this. Like this and like this. So this area will be the area of the minor sector. Okay. First, we will calculate the area of the minor sector. This is minor sector. If this minor sector is making an angle of theta, not minor sector, if this arc AB is making an angle theta at the center of the circle, O is the center. O is the center of the circle. Now focus here. What is the area of the whole circle? Pi r square. Area of whole circle. Whole circle. What is the meaning of the whole circle? For the whole circle, the length of the arc will be the circumference of the circle, and this theta will be the 360-degree angle. This theta will be 360-degree angle. So I can say that if this theta will be 360, if this theta, okay, will be 360-degree, you can write here angle and here area. If the angle theta is 360, then for that 360 angle, there will be a complete circle, and for that complete circle, the area will be pi r square. Okay. Now, for unit degree, for 1 degree, for 360, this much of area is there. for 1 degree of the sector, the area will be pi r square divided by 360. So you will divide pi r square with 360. Now, for any particular angle theta degree, the area will be theta degree multiplied by pi r square divided by 360. Now, finally, you will have the area of the sector. Will have area of sector with center angle theta. Center angle theta, that is equal to, this will be the area. Okay, if theta will be the angle at the center like this, then this will be the area theta multiplied by pi r square by 360. This is in degree. So theta degree multiplied by pi r square divided by 360 degree. Okay, so in this way you can calculate the area of the sector, and this is the area of the minor sector. Okay, this is the area of the minor sector. Now for the major sector, this is the minor sector. Now for area of major sector, what you will do? Area of major sector. What you will do for the area of major sector? This area is there for the minor sector, and major sector area is this. So what you will do? You will take total area of the circle and you will subtract area of minor sector from that, and then you will get the area of the major sector. So area of major sector is equal to pi r square, means area of circle, minus area of minor sector. So keep in mind this thing. Write down. Corresponding to the minor arc, there is a minor sector. Corresponding to major arc, there is a major sector.
Done, sir. Sir, can you scroll down?
Scroll up or down?
No, sir, down.
It's fine if this is okay.
Okay, sir.
So now we will calculate the length of the arc. Length of the arc. Length of arc. This is a circle, and this is suppose an arc, and this is the center of the circle, and the end points of the arc are like this. Like this, and these endpoints are making an angle theta, and this is a radius, and this will also be radius. We have to find the arc length. This point is suppose A, and this point is suppose B, and length of the arc is L. Arc length is L. Okay, so this arc length is L. This small L is the arc length. Now we can calculate very easily in the same way as we have calculated the area of the minor sector. We can calculate the area of this length of arc AB. Okay. So how we will calculate? Unitary method we will apply. Unitary method. What is the meaning of unitary method? Here we will write angle, and here we will write length. If I say that for the 360-degree angle, what will be the length? In case of circle, if this angle become 360-degree, then the length of this will become the whole circle. What will be the length of the whole circle? Circumference of the circle, that is 2 pi r. So length become 2 pi r. Now for unit degree, the length become 2 pi r by 360. Okay. Now for any particular angle theta, the length of the arc will be theta multiplied by 2 pi r divided by 360. So length of arc making an angle theta at center is equal to theta multiplied by 2 pi r divided by 360. Okay, this is theta degree. Okay, so this will be the length of the arc. Length of the arc means this length AB, this length. Okay, we are talking about this length. This is the length of the arc. Write down.
Done, sir.
Okay. Find the area of the sector of a circle with radius 4 centimeter and of angle 30°. Also find the area of the corresponding major sector. So in this question, this is a circle and this is the center of the circle, and there is a sector like this making an angle of 30°. This angle is 30°. So this is the sector and this is also a sector. So this is a minor sector, this is a major sector. So they are asking find the area of the sector of a circle with a radius of 4 centimeter and of angle 30°. So radius 4 centimeter. This radius is 4 centimeter. Okay. This radius is 4 centimeter. Radius is 4 centimeter and this is 30°. So what I told you, the area of this sector will be area of this minor sector. This is a minor sector. Area of minor sector is equal to what was the formula? Theta degree multiplied by pi r square divided by 360°. So theta is 30° multiplied by pi we will use this is given in the question. Use pi is equal to 3.14. So you will always use 3.14, not 22/7. Okay. So 3.14 and r square means 4 centimeter square, 4 square divided by 360. So you will cancel it out 30 and this will be 3 ones are 3 and 3 2s are 6. So it will become 4 4s are 16 and this is 12. So it will become 4 4s are 16 and 4 3s are 12. So it will become 3.14 4 4s are 16 or 4 3s are 12. So I think the answer will be 4. I have already calculated the answer, so it will become 4.18 centimeter square. This will be the answer of area of the minor sector. Now for the major sector, what we will do? This is the major sector. This is the major sector. For the major sector, first we will calculate the area of the circle and we will subtract this area, and this area is the area of the minor sector. So area of major sector, is equal to pi r square, means area of the circle, minus area of the minor sector, that is 4.18. Okay, you can write here area of minor sector. Area of minor sector. So pi r square, pi r is 4 square, minus area of minor sector is 4.18. So I think this will become, you will put the value of pi as 3.14 given in the question. 3.14 multiplied by 16 minus 4.18. This value will be equal to 50.24 minus 4.18, and finally the answer will be 46.06. centimeter square. So you can see area of the minor sector is this. Area of the minor sector is 4.18 centimeter square, and area of the major sector is this. If you will just add both the areas, na, so you will get area of the circle, because area of the minus, this is the minor sector, this is the major sector. Okay, write down. Example number 2, chapter number 12. Completed.
Yes, sir.
So now we will see area of segment. area of segment. Area of segment. So area of segment, this is a circle, and I'm drawing a chord. Suppose this is a chord, and this chord intersecting the circle at these points, and this is the center. Okay, this is the center. So now I am joining these points to the center, and these point to the center. And what I told you before that, what is the area of the segment? This is the minor segment, and this is the major segment. This is the major segment. This is the center of the circle. So this portion is the major segment, and this portion is a minor segment. We are calculating first the area of the minor segment. This is the minor segment. Okay. So for that, for what I am doing, these are 2 points of the chord joining with the center. Okay. So now I am joining these points to the center. This is the center. And this angle is theta. This angle is theta. Now, what is this whole area? This whole area, you can say it will be the sector, na? This whole area, suppose this is O. This is O. This is A. And this is Y. And this is B. So this whole area O, A, Y, B is the area of this. It will become area of sector. Is it or not? You can see here. This area is the area of sector.
Yes.
This is a sector. So this part becomes a sector, but we want this area. We only want A by B. So you can say area OA by B is a sector, or you can say is minor sector. Minor sector having area. What was the area? Equal to what the area is theta multiplied by pi r square divided by 360, if r is the radius of this circle. So this total area we have now, but we want this area. We want this area. So for calculating this area, what we will do? This is a triangle OAB. So we will just calculate this area OA by B, means area of the sector, and we will subtract the area of triangle from that, and we will get this area. Okay, so area of minor sector segment, sorry, not a sector. This is the minor segment. This is minor segment, not sector. So area of minor segment is equal to area of this whole sector, area of this minor sector, minus area of triangle. So area of sector with angle theta. Sector with angle theta minus area of triangle OAB. Okay, area of triangle OAB. Area of triangle OAB. So in this way, we can find area of the segment. Write down, and in the next class we will solve some of the question on this area of segment. Done. Completed. Okay. Completed now?
Yes, sir.
Okay, Azaan. So we will meet in the now we'll meet at next class.